Hello, this is Klaus from Electronics Unmessed. Today we are completing our project for a new stylish analog meter. We will talk about the 3D printed casing. Guys, today there is another nice case to build yourself. All construction plans and the Arduino code were discussed on the channel and made available for download. In previous videos I have shown the construction of a retro design gauge. Not only the look is retro, but also the control of the pointer, which can imitate the dynamics of a classic pointer instrument. I find small stepper motors very interesting for maker projects. That's why I developed a universal hardware design that can be used to implement multiple functions. For this project I'm applying that hardware. I linked the previous videos. And this time I'm aiming for a fast reacting gauge instead of a sluggish retro looking instrument. We need to accelerate and decelerate our stepper motor to get it to spin at its maximum speed. This is achieved with the right code, which I've been experimenting with for a while. If you're interested in the details, check out the previous videos. As you can see, I've already designed a dial for a ref counter and a speedometer. I also provide the two dials as a PDF file. A housing in the style of a classic sports car ref counter would of course be cool for this. That was my basic idea, which I immediately try to capture with a hand sketch. That way I can get a feeling of the dimensions and the style elements. In the meantime, I developed my FreeCAD skills further. And that makes it even more fun for me to construct things for 3D printing. The new housing consists of two parts that are held together by four 70 mm long M6 screws. Inside we have a plate for the dial and of course a pointer. And then we have a white body illuminated by four white LEDs. The LEDs are inserted into these holes from below. The light is diffused by the white PLA material and then illuminates the dial. For the front I created an anti-glare ring, which is positioned with studs and later glued. With this trick I get a nice surface structure on the front panel and on the anti-glare ring. Experts know the problem. It's hard to get a nice finish with offset surfaces. An acrylic glass pane with a diameter of 10 cm is embedded in the front of the housing. The body is prepared to mount two boards on top of each other with 50 mm long M3 screws. This allows the position of the two circuit boards to be varied a bit, for example if you want to use a different stepper motor. I provide all files in FreeCAD format and as STL format. And here's a little trick to create realistic animations in FreeCAD. I use the placement function to rotate the pointer. For 3D printing, you might want to go the easy way with PCBWay, the sponsor of this video. You will find a CNC and 3D printing section on the website. You can easily upload your design data. And guys, I'm so impressed by the variety of materials I can choose from. Besides numerous plastic options, there is even metal, and it's great to see the price immediately with every change you make. And this is what the device looks like when it's finished. That's cool, isn't it? And the thing works really great. I calibrated the voltage divider for the voltage measurement with my multimeter and a laboratory power supply. By the way, assembly was easy. I left a hole on the side so that the USB port remains accessible, because I don't want to open the device every time when I want to change the code. Also, I can then power the device from an USB charger or a PC. The electrical connections are on the back. I use Lustre terminals for that. And yes, the thing is really damn fast, at least for a mechanical gauge. And that's why I said to myself, I absolutely have to test the instrument together with a slot car racetrack. And what's next? I will do more experiments based on frequency measurement and sensors. There is a number of new projects on my mind applying the concept. So subscribe to the channel and hit the bell so you don't miss the new episodes. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.